everyone. My name is Julien. I'm one of the organizers here behind this conference. With me today is Kelly Thomas, who will be the chair of the session, as well as Julien Favreau, the PhD student with the SDS project, who will be hosting this talk. Before that, I just want to mention that we have a Q&A session with Kate Wong, the senior editor of Scientific American, right after this talk. So please tune in for that. However, before that, we have a very exciting talk here with Julien. Please take it away.
Thank you. Well, I want to start off by thanking the organizers of the conference and all of the attendees, which I cannot see, sadly. But anyways, today I will be exploring the way that we can source artifacts to their geological outcrops by drawing on our team's past research, as well as my ongoing doctoral research based at Oldupai Gorge in Tanzania. In doing so, I'll be drawing a little bit of inspiration from the present, detailing how we go about sourcing artifacts, and really highlighting the implications that this holds for our reconstruction of hominin behavior and stone tool technology through time and space. So in preparing this talk and really honoring a facet of this conference, I was looking to draw a link between the archaeological record and contemporary times. So in thinking about prehistoric technology on an almost daily basis, I couldn't help to draw a link to recent technological innovations that have impacted our lives in one way or another. This is particularly so during a global pandemic when many facets of our lives rely on digital technologies like internet, mobile phones, and cloud servers, only to name a few. But still, another innovation, which is just as recent, is one I would like to draw your attention to. Known as blockchains, they have really revolutionized the digital world of economics and business, particularly for the virtual exchange of liquid assets through cryptocurrencies like Bitcoin. Now, the reason I emphasize this particular innovation is because it's a useful analogy to how archaeologists can go about sourcing stone artifacts at their entry point into the economies of Pleistocene hominins. So shifting from contemporary innovations to those that have come to define the behavior of Plio-Pleistocene hominins, the purposeful fracturing and utilization of stone tools represents really the first traces we have of an archaeological record that stretches back approximately 3.3 million years ago with what is known as the Lomekwian, defined by its large cores and flakes. Some 2.6 million years ago, this was followed by the emergence of the Oldowan industry, which is characterized by the occurrence of artifact types like cores, flakes, debris, and hammerstones. And almost 1 million years later, the Acheulean industry emerged among hominin tool makers. And this technology can be broadly defined on the basis of hand axes, cleavers, and picks, which can almost be equated to as index fossils. So as archaeologists, we can break down the manufacturing process behind these stone tool technologies using a number of methods and theories. Here I'm using the middle range theory known as the organization of stone tool technology, through which we can arrive at environmental, technological, ideational, political, and sociocultural explanations for our archaeological data. So these levels of analysis can almost be thought of as factors that influence the stone tool technology of a social group. Here, I will focus on the factors that fall under the environmental line of inquiry. So what do we mean by this exactly? Well, we know that raw material sources were heterogeneously distributed across the paleo landscape. What's more, the shape, size, and mechanical properties of stone at each individual outcrop can be drastically different, meaning that if a group of hominins wanted to break open bones to access marrow, chances are they weren't going to be using a fragile rock type like obsidian to carry out this task. So with this in mind, there are behaviors that precede the production and utilization of stone tools at an archaeological site, including the selection of stone itself and its transportation across the paleo landscape. Now, most importantly, these behaviors are detectable in the archaeological record. In fact, stone transport is not only visible in deep archaeological time, but of course, also when we study the discard patterns of living non-human primates, most notably chimpanzees, who are our closest living relatives and exist in a technological niche evidenced by the transport of stone hammers, usually on the order of a few hundred meters per transport bout. So when we conduct a comparative analysis of stone transport between Plio-Pleistocene hominins and chimpanzees, it's clear that at some point in our evolutionary history, stone transport really materialized itself as a unique behavioral facet of the hominin lineage in terms of its intensity and amplification. And this is particularly so when we consider the significant jump in stone transport distances recognized at some key Oldowan sites, one of which I'll be talking to you about today. Recalling the analogy of blockchains, this now brings us to how archaeologists can go about sourcing stone artifacts through a technique known as geochemical fingerprinting. So at a fundamental level, sourcing stone tools, their geological sources, requires the establishment of a reference collection by obtaining a representative set of rocks from different outcrops that were available during the occupation of an archaeological site. At this point, we would characterize our samples using a geochemical technique, and we would then run a number of statistical models with the underlying goal of identifying differences among the sampled outcrops. Assuming we're successful, now say that we excavated at a nearby archaeological site, we would then characterize our stone tools using the same technique as our geological samples. And from here, we could identify from where hominins procured rocks. After ruling out the possibility that geological forces like ancient rivers could have naturally transported raw materials onto an archaeological site, we could then go so far as to say that the site's occupants may have directly visited, outcrops A, B, C, and D, where they selected raw materials, transported these stones onto the site to carry out their tool-making process and conduct their daily activities. So starting in 2017, our team began an intensive research program as proof of concept for stone artifact sourcing. And so it is this research program that I'll explore with you here today. So in turning to the geological setting of the Oldupai Gorge Paleo Basin, on your upper left, we have an inset map representing the lithostratigraphic units that are exposed in northern Tanzania. And in the rest of the slide, we have a map of the Oldupai region with the sedimentary, igneous, and metamorphic outcrops symbolized in different colors. In the middle, near the Paleo Lake that once existed, there were chert deposits that formed via sodium silicate precipitation. And these deposits would have been intermittently exposed during low stands, which explains why so few archaeological sites actually contain chert artifacts. In terms of volcanic sources or igneous rocks, there were 5 major volcanic centers symbolized in red, and these would have deposited igneous clasts into the basin in the form of conglomerates that would have then been available for early hominins. And symbolized in white and green are the metamorphic outcrops. Some of these are associated with the Mozambique belt, which is Neoproterozoic in age, and these exposures would have formed really prominent inselbergs on the Paleo landscape during the deposition of early Pleistocene sediments. So with these outcrops in mind, our research question was quite straightforward. We asked, do outcrops have unique rock types at the macroscopic, petrographic, and geochemical scales? If so, it would then be feasible to source stone tools to individual outcrops and address a variety of research questions ranging from mobility to curation, stone selection, and all sorts of correlations between tool-making strategies and specific rock types. So to answer this research question, we employed a number of analytical methods to characterize the raw material sources, including macroscopic classification, thin section petrography, electron probe microanalysis, and energy dispersive X-ray fluorescence spectroscopy. So for XRF, we analyzed a total of 18 elements, including the 8 major oxides and 10 trace elements listed there. And so in the remainder of this presentation, I'll discuss the results in order by going from the visual to the geochemical and discussing some corresponding source assignment for stone tools. So turning now to our hand specimen analyses, ultimately we found that different varieties of red, white, and gray quartzites can be found at different outcrops, thereby supporting our null hypothesis. However, green quartzites, at least on a local scale, are exclusively found at 2 outcrops, and this is something that we'll return to shortly. Turning now to our petrographic or thin section analyses. So ultimately, by doing some comparative analyses, we found that the mineral fuchsite, which is responsible for giving quartzites a green color, is actually unique to the outcrops that are known as Neighborsoit kubwa and Neighborsoit Ndogo. And so this actually corroborates with our hand specimen analyses that I just presented on. What's more, we found another co-occurrence at the petrographic scale concerning Storalite and Kyanite bearing quartzites. These are characteristic of the outcrops of Naisiusiu and Endonio Oculae, which are located in the Western Paleo Basin here. So here we have some petrographic data to expand on the previous slide. So on your upper left is a backscattered electron micrograph showing quartz, muscovite, and the red circle designates the mineral fuchsite. And on the bottom left, we have an EDS spectra, which is almost a perfect match for the mineral muscovite. But what actually allows us to identify this as fuchsite is the small chromium peak that is circled in red. The other co-occurrence on a petrographic level concerns, again, the Storalite and Kyanite bearing quartzites. So on your upper right is another backscattered electron micrograph where you have quartz with sutured boundaries together with Kyanite and Storalite, which have characteristic platy habits. And on the bottom right is an EDS spectra of Kyanite evidenced by the characteristic spectra from aluminum and silica. So as you'll recall, fuchsitic quartzite is exclusively found at the outcrops of Neighborsoit kubwa and Neighborsoit Ndogo. So considering this green color is quite distinct, we conducted a review of previously described stone tool assemblages from Oldupai Gorge to see whether this raw material had been reported. And what do you know, Mary Leakey in Oldupai Volume 5 referenced, and I quote, a double-edged side scraper made on part of an unusually thick slab of green tinted quartzite coming from the site of JK West, dated to about 1 million years. And most recently, McHenry and Delatorre reported a total of 5 artifacts, undetermined types, made from green quartzite from the sites of HWK East East and EFHR, which are Oldowan and Julien, respectively. Here we have additional examples of fuchsitic quartzite artifacts from a number of different archaeological sites at Oldupai Gorge. So on your left, we actually have examples of from the British and Peabody museums, including some cleavers, hand axes, and a core scraper on the bottom left. And on the right, we have a large trihedral pick from the Bed 2 site of TK, which is dated to about 1.3 million years ago. And you can clearly see 2 linings of fuchsite minerals. And in our excavations next door at the site of Ngaji Naniori, we recovered a split flake made from this same type of raw material. So what does this all mean from a spatial perspective? Because fuchsitic quartzite is unique to the outcrops of Neighborsoit kubwa and Neighborsoit Ndogo, we may infer that both Oldowan and Julien occupants at these archaeological sites shown here return to the outcrops over a 1 million year interval. What's particularly striking is the site distribution pattern, where you can clearly see that the sites containing this raw material are really constrained to the Eastern Paleo Basin, whereas of now, there are no known sites in the Western sector with evidence of green quartzite, which raises a testable hypothesis for future research, or it could also be a result of the history of investigations, also focusing on the Eastern sector. Now I would like to shift to our geochemical analyses of the regional quartzitic outcrops, with the underlying goal of detecting differences as a means to source stone artifacts. So using XRF as our characterization method, we ran a discriminant function analysis to calculate the probability for the correct classification of 42 quartzite geological samples to their respective outcrops, which in this case numbered 5. And in so doing, we got an 86% classification success rate, which is pretty good. And here you can see that with our first and second components plotted, which account for actually 90% of the variance, the groupings are quite distinct. And this is primarily resulting from trace elements and the occurrence of magnesium oxide. So from the time we published our first results that offered quite a bit of promise, we've continued with the characterization of quartzite geological samples. So shown here is a discriminant analysis biplot that includes the first and second components for 125 geological samples. And the first two functions of our statistical model account in this case for 87% of the variance, which is a little bit lower than our earlier model at about 90%. But still, when we performed a cross-validation to assess the initial hit ratio, we got an accuracy of about 75%, which in statistical terms is relatively good since it is above the random chance baseline of about 20%. So given the proof of concept from our XRF characterization studies, we recently put our reference collection to the test by analyzing quartzite artifacts from the Oldowan site known as Oldupai. This site is located in the Western Paleo Basin, as you can see on the inset map, and has been shown to be the earliest archaeological site in the entire gorge. So as mentioned, we analyzed here 24 artifacts last summer using energy dispersive XRF, and we compared the geochemical concentrations with those from 125 samples from 5 local outcrops. The studied artifacts came from our trenches 3 and 6, which you can see on the stratigraphic section on your right. And on the left is another biplot of our linear discriminant model that includes the first and second components that again account for 87% of the variance here. So after performing a cross-validation to assess the initial hit ratio, the chance corrected value is at 75.2%. This basically means that we can attribute with 75% accuracy the raw material sources for these 24 stone tools. So moving beyond the numbers, here we have the quartzite artifacts from Oldupai that were plotted on the previous slide. The 3 artifacts up top were manufactured from quartzite of an unknown source, since they consistently plotted outside the convex hulls of the 5 sampled outcrops. In the middle, we have 3 lithics that are a geochemical match with the outcrop known as Naisiu. And based on our paleogeographic projections, the outcrop of Naisiu would have been located about 400 meters away from the archaeological site at the time of occupation. What's particularly interesting is that the remainder of the artifacts studied from Oldupai are a geochemical match to the outcrops known as Neighborsoit Kubwa and Neighborsoit Ndogo. And you can see just on this map here that both these outcrops are located in the Eastern Paleo Basin, some 12 kilometers away from the archaeological site. And so these results essentially indicate that Oldowan tool makers at Oldupai probably foraged from east to west while transporting usable flakes and cores. So to close, I would like to just reiterate some of the primary conclusions that can be drawn from this presentation. First and foremost, our characterization studies of the quartzitic outcrops adjacent to Oldupai Gorge really serve as proof of concept that stone tools are sourceable. Quartzite stone tools are sourceable on a local scale. Second, based on our macroscopic, petrographic, and geochemical studies, we may say that hominin tool makers who occupied the Eastern Paleo Basin were certainly not in short supply of raw materials, given their exploitation of characteristic green quartzite from either one of two nearby outcrops. And finally, the Oldowan tool makers who occupied the site of Iwas Oldupai between about 2 to 1.8 million years ago were regularly transporting quartzite tools when forging along an east to west trajectory. These results, I would argue, not only hint at the curation of tools from one occupation site to another, but also the degree to which technology was embedded in the daily movement in the anticipation of future needs, or perhaps even risk mitigation. So overall, I think this evidence really puts into question the assumption that early Pleistocene hominins had simplistic and opportunistic raw material exploitation strategies, meaning that their stone tool economies, or going back to this analogy of blockchains, I think you could argue were a little bit more complex than what is commonly imagined. So with that, I just want to thank the following institutions, agencies, the Maasai community of Oldupai Gorge, and all of you for attending my presentation. Thank you.
Thank you for a really cool presentation. I'm not a geologist, but I believe I learned something.
That's good.
With that, we do have a couple of questions, so I will get those. First off, how far away from the outcrops have lithics with the Fuchsite been found? Can we say something about the area of occupation using this information?
Yeah, so in this case, for this green quartzite, we're usually talking within a radius of about 2 to 3 kilometers from the furthest archaeological site. So it's not overly far, and because these outcrops would have formed really prominent inselbergs on the landscape, it could be potentially argued that some of these quartzitic or fuchsite quartzite raw materials could have been picked up a lot closer to the archaeological site as like talus deposits. But one thing I would say too about the area of occupation, it's difficult to really say this at this point, because a lot of the archaeological studies, like as Arturo was talking about earlier, a lot of the archaeological studies and fossil studies have really focused on the Eastern Paleo Basin. So it's really difficult to say whether this is an artifact of archaeology or if it's a real sort of pattern that we're seeing on the landscape in terms of hominins that are occupying kind of the Eastern Paleo Basin are really only selecting raw materials from nearby outcrops, whereas the ones that are kind of foraging along the entire landscape are really making sure that they're equipped, if you will, before kind of venturing out further west. So it's a little bit difficult at this point, but I think we hope to kind of contribute to that a little bit more in the future.
All right. Then we have, does the assemblage show any change in the preference of the raw material from the Lamequian to Oldowan, or say from Oldowan to a Julien?
If I understand the Lamequian correctly, I think most of the raw materials were coming from a nearby riverbed draining a volcanic center or something like this, or a volcanic ridge. So all the raw materials there, I believe, are igneous in nature, whereas at Oldupai Gorge, you have the Mozambique belt that underlies a lot of the sedimentary deposits. And so you have some massive inselbergs that would have been there on the paleo landscape. And a lot of these inselbergs are metamorphic in nature. So you have some granite gneiss, different types of quartzite. And then further to the southeast, you have all the volcanic highlands. So I wonder if, it could just be a fact that at Oldupai Gorge, we have a lot of quartzite represented, and Oldupai Gorge kind of stands as a reference site for elsewhere. But there does seem to be a trend across Eastern and parts of Southern Africa where quartz-rich raw materials, silicon-rich raw materials were really commonly utilized. And then in terms of, let's say, the Oldowan to the Julien, I think one of the big differences, at least as at Oldupai Gorge specifically, is with the production of large blanks to then shape into large hand axes and picks and cleavers and what have you. A lot of the time, those raw materials are igneous in nature. And so the idea would be that the hominins, the hominin tool makers were actually potentially going a little bit further away from their occupation sites to procure raw materials closer to their volcanic centers to get some really large blocks. So that's one trend that we could see at Oldupai Gorge, but it kind of remains to be securely shown where the Acheulean tool makers were getting the raw materials, whether it was from an ancient riverbed or a little bit closer to the volcanic centers themselves.
We have a bit of a follow-up question to that, I think, that you just touched upon there. Given that the quartzite material was being transported several kilometers to be processed, how big were the quartzite blocks being transported and how were they carried?
Yeah, that's a good question. I'm not exactly sure how they were being carried. I would say that they're not overly big, but in this case, we're talking about some tools that are 2 million years old. So this is before the known appearance of Homo erectus, and so presumably in their hands. I think there has been some studies on the cumulative transport of stone by chimpanzees showing that they can basically move stone up to 2 kilometers away. I think we can safely disregard kind of that middle range model. I think it probably was, in either 1 or 2 kind of bouts of transport. I think it could be reasonable to assume that. But in terms of how they were carried, I wish I knew.
That would be nice. And then one last question to round it off here. How do you see these methodologies developing in the future?
Yeah, I think for any of the methodologies, there are a number of factors that we would want to consider, and I think some of them is like the obvious cost benefit analysis that one wants to be doing. I think we also want to be considering the accuracy of these methods, but at the end of the day, I think there is really good potential for the kind of geochemical facet to expand. And I would say too that while petrography can be destructive, it is very valuable, and I think there is maybe some untapped potential in terms of thin section petrography. But again, you come into issues there around the ethics of doing destructive analyses on artifacts. So I think the natural gateway would then to go at the geochemical fingerprinting, as I kind of expanded upon, and and reassessing some of these age-old beliefs and assumptions that quartz-rich rock types can't be sourced, at least on a local scale. I think we're all very much aware that you can't be sourcing tools made of this raw material across the landscape in the same way that obsidian is done. But I think we're all comfortable by doing that on a local scale. And so I think it's this idea of we need to really kind of consider our conceptual spatial scales when we're doing this type of work. And I think as long as we have our proper units of analysis to do this type of research, I think we're very much able to make strong inferences about the archaeological record and that.
Okay, thank you so much for answering the questions and for a really cool talk. In order to facilitate a smooth transition to the next talk, I think we will end it off here. And just another reminder that after this, we will have Kate Wong doing the Q&A, as well as some other contemporary talks, all of which will be available on demand video later. Thank you once again, Julien.
Thank you.